doing an example for resultant vector calculations. So let's say we have an object, like a box, that is being put under the action of two different forces. One force is pulling the object to the right, parallel to the ground. This force has a magnitude of 30 newtons. Another force is acting on the object to the left at an upwards angle. The magnitude is also 30 newtons, but the angle in this case is 20 degrees. So, how would we calculate the resultant vector? Now remember, the resultant vector is defined as a single vector with the same effect as all the vectors combined. So to do this, I'm going to make use of the graphical method. We start off by choosing a scale, and my scale is simply going to be 1 centimeter is equal to 10 newtons, which means on my drawing 1 centimeter will be 10 newtons, representing 10 newtons. Then we choose a starting point for our drawing, and we get a ruler and a protractor for our calculations. You can choose either one of these two forces to draw first. I'll be showing both just to demonstrate that you get the same answer. Starting off, the first force is 30 newtons to the right, so I'll measure out 3 centimeters to the right. Draw an arrow to indicate that it is a vector quantity. Then we take the second vector and move it to the head position of the first vector. So we take the tail end and we start drawing from the head of the first vector. We first measure out an angle using our protractor, and the angle is given to us as 20 degrees. So I measure out 20 degrees on my protractor. I take my ruler, and this is 30 newtons, so it would be 3 centimeters. You can choose any way to do it. I'll start here and measure out 3 centimeters like that. So this first vector is 30 newtons to the right. The second vector is 30 newtons at an angle of 20 degrees north of west. How would we get our resultant vector from this sketch then, which has been drawn to scale? We simply take the distance from the starting point to the end. So we draw a line there, and measuring it out, we find it to be exactly 1 centimeter. So we see that this is 1 centimeter, which means that the resultant vector will be 1 centimeter multiplied by the scale of 10 gives us 10 newtons. Now, since this is a vector quantity, we also need to give the direction of our resultant vector. To get this graphically, we use our protractor, place it on the line, and we can measure this angle from 0 up to the red line to be 70 degrees. So that angle there is 70 degrees. So what we add as direction, we've got two options. I'm going to say 70 degrees north of east. There's a few ways you could do it. You can also say 20 degrees east of north, or you could even just say with a rotation of 20 degrees, taking 0 as north. So those are the three options of your direction, and I'm just really going to show you that you can choose either vector to draw first and you'll get the same resultant. So using the same scale, I'll draw a new origin point here, and I'll draw the angled force first. So if I take my angled force of 20 degrees being the angle, I measure out 20 right there. I measure out 3 centimeters. Now I simply take the horizontal force and I draw it horizontally to with the tail to the head. So I draw 3 centimeters there to the right, and my resultant force will once again be from the start to the finish. And what do we notice? If we measure it accurately with our ruler, we see that it is 1 centimeter again. We'll notice that the direction is also almost exactly the same, with human error causing it to differ slightly in some cases. So the resultant, drawing it in the other order, will just be 1 times 10, which is 10 newtons. And there we have our magnitude. Remember, vector arrows, the magnitude is given by the length and the direction is given by the arrow point. So let's quickly use our protractor to measure out the angle. And in this case, the angle is going to be a bit different from the previous one. We get 80 degrees. So I'm going to say the 80 degrees north of east. Now we allow some leniency. I might have been a bit inaccurate in my drawing, but these are the steps that you have to follow when drawing the graphical vector.